Hello everyone, welcome to lecture 5. In this lecture, we are going to learn about the concept of suitability analysis and to understand how GIS tools are used for suitability analysis in an urban planning context. Suitability analysis is important for urban planners and some other disciplines for multi-criteria evaluation, for comparison and rank candidate sites based on the certain criteria we define and select for a project. Using suitability analysis techniques, we can answer questions such as which region of a country is most suitable for future expansions? Within the selected region, which area is most appropriate for sales growth? Within the market selected for expansion, which candidate site is the best location? Other questions that can be answered by a suitability analysis include which area in a city is the best location for future high-density urban development, where to locate ski areas, and where to locate firefighting crews to best fight fires in a dry season. For urban planners, suitability analysis is the process to evaluate best location for a specific land use or activity. Indeed, in suitability analysis, we know what is the land use, but the best location for the land use is unknown. The role of planner is to undertake suitability analysis for finding the best location for the known land use. Therefore, planners need to have a lot of information regarding the location and synthesize the information to find best location for the specific land use. GIS is popular for this task of site selection and suitability analysis because it provides tools to be able to prepare location data for various criteria and evaluate the criteria to find the best locations for the specific land use. One main question for all suitability analysis is that how to organize input data sets. For organizing the input data, the first step is to look at the objectives of the project and see what the basic requirements for the best location of a land use are. Indeed, we need to define our criteria for finding the best location of the land uses. Then we need to prepare appropriate data sets for each criterion. For example, to find the best location for a primary school, defined criteria by a group of planners are to: first, consider the school far from the existing primary schools where there is a need for a new school. Second, locate the school in a relatively flat area, not in a hilly area. Third, locate the school in a 500-meter distance from existing recreation sites such as playground. Fourth, locate a school at least in 1 kilometer distance from existing hospitals. After making GIS layers for all these criteria, we need to transform input data in a way we can rate all the best locations for all the criteria with a same range of values. Of course, the importance of all the criteria is not the same. Therefore, we can add weights to the prepared layers of the criteria based on their importance for the final location of a school and then combine all the layers to find candidate sites. An expert or a group of experts will evaluate the candidate sites to select the best site at the end. What are the main steps when we work on a suitability analysis? There are 6 main steps outlined in this slide. The first step is to define the problem. Second step is to identify and derive the important criteria for the analysis. Third step is to transform the values to a common scale across all the criteria layers. The fourth step is to assign weights to each criteria based on its importance for the analysis and then combine all the weighted layers. And the fifth step is to locate the phenomenon, and the last step is to analyze the results by an expert or a group of experts from different disciplines. Let's talk about these steps in more details. As we said before, the first step in a suitability analysis is to define the problem. When we define the problem, it is necessary to know what our goals for the project are and establish a way to evaluate the criteria. We also need to create submodels to define all the layers important for one criterion. Definitely, the importance of various criteria in a suitability analysis is different. Therefore, weighting the criteria based on the level of their importance is crucial before combining all the layers. For example, for a ski site, slope is more important than aspect derived from elevation data. Therefore, the weight assigned to a slope will be higher than the weight assigned to aspect in such case. When the candidate sites are detected, it is necessary to see which site is more appropriate based on other factors, such as the shape and size of the identified candidate sites, derived from the suitability analysis, or a special relationship between the candidate sites with other regions. For example, for a ski site, we might decide on a more compact candidate site. Good to know that a circle and a square are the most compact two-dimensional shapes in a geographic context. As discussed, the last step to analyze the results before making the final decision. In the analysis step, we need to see whether the best location we found meets the objectives of our project. Okay, let's summarize what we have learned in this lecture. We learned that GIS provides required tools for suitability analysis that is very important for data-driven decision-making in urban planning. Urban planners can find best locations for land uses and activities based on the criteria they define at the beginning of a project using suitability analysis within a GIS environment. Urban planners must not 100% rely on the results of the suitability analysis from GIS techniques, and consultation with experts from different disciplines is necessary for making final decisions on the best site. This is the end of pre-lecture video for week 5. Thanks for watching.